All right, I guess we will get started now. Welcome everyone to another GMDSI webinar. Before we get started, again, questions and comments, please into the Q&A section, not into the chat. And we are recording today's session, just so everyone has that in mind. Today's webinar is very much focused on the practitioners in our space of applied groundwater modeling. And we're specifically going to present some new materials to help you upskill in the realm of applied decision support or predictive modeling using the Python ecosystem. So I'm Jeremy White. I'm a hydrogeologist with Intera. I've been with Intera about 3 years now. Before that, I was with the USGS, and I did a stint at GNS. And I'm joined today by Briak Hemmings, a fantastic hydrogeologist from GNS Science, and Rui Hugman, formerly of GMDSI, now with Intera. I've asked both Briak and Rui to chime in and interrupt and correct anything dumb that I might say. So I'm going to put them sort of on notice to speak as we move along today. So briefly, let's see if I can get the slides to work. Sweet. So a quick outline of what we're going to talk about. Some motivation about why I think and we think scripting is a viable approach to applied predictive modeling. And then I'll go over a high-level overview of the materials we've developed, and then we'll take turns diving into deeper bits of how those materials are structured and designed. And then we're going to announce a free course that you might be interested in at the end of the webinar today. So the motivation, obviously, is predictive modeling. This is the thing that GMDSI is most focused on. And the thing I think that really distinguishes predictive modeling from explanatory modeling is that predictive modeling is more than just a simulation. It's a simulation paired with some sort of advanced predictive analysis, or maybe more than one, maybe some analyses. And so you have to have a necessarily simplified numerical representation of the system usually, and then you pair that with one or more of these analyses to yield what we might call predictive analytics, things that can be used in the decision support setting to help manage water resources and make contentious decisions. And because of that pairing, I think that's one of the things that makes predictive modeling and decision support modeling hard, is that not only do you have to be good at modeling and model building and understanding the physics of groundwater movement, but you also have to know this whole other set of things around these advanced analyses that you want to do with the model. So there's a list of topics here of things that I think require at least some level of understanding when you want to do these sort of predictive analyses with modeling. And so if you're a decision maker or a consumer of the modeling results, maybe a cursory understanding of the theory and the concepts, and of course, picking up all the jargon that we use, is enough for you to participate from your role in the modeling process. But us practitioners who are down in the trenches, we need to know quite a bit about the theory and the concepts. And more than that, we have to know how to translate those theory and concepts to work in real world settings at scales that are pretty large, right? So that's what we would call the mechanics and the workflows of predictive modeling. And they can be very involved. There's lots of moving pieces and subspecialties. And I think to the point that this is that sort of can't see the forest for the trees analogy, that many of us suffer from getting so bogged down in the mechanics and the workflow of the thing that we lose the ability to do the scientific interpretation that people want us to do, and that frankly I think a lot of us want to do ourselves. Is we want to do the predictive analysis, we want to look at the results, think critically, do the science piece of it. But I think in many settings we get so bogged down with each one of these little aspen trees that we can't zoom back and actually see the forest of the analysis that we're doing. And so another analogy I've been using lately is the tiramisu of predictive modeling, or I was telling Rui we could also call it the tiramisu of suffering. And so this tiramisu, like there's layers, right? And so you've got the theory and the concepts, and then you have the mechanics, which is applying the theory and the concepts of each one of these things to a real world setting. And then the workflow is like stitching each one of these mechanics together to do some sort of coherent analysis. And then on top of that is everybody's favorite stuff, the IT, the data management, the computer restarting at 2 a.m., all those fun things. And so as a modeler, how do we consume? Well, I'm going to take this contrived analogy a little bit further. I'm going to say that the fork in this analogy is scripting and coding, right? That's how I think, at least for me, I best consume the workflow of predictive modeling. And so Why do we like coding and scripting? Well, it's because it lets us, in a large part, offload a lot of those mechanics and the workflow pieces into the scripts to give us more opportunities to do the scientific interpretation, to do that predictive analysis and think about the theory and the concepts. Scripting is not the only approach. There's been other GMDSI webinars that talk about this. I encourage you to check those out if you want to get a broader view of the landscape. And if we're going to talk about scripting and coding, we probably have to talk about Python. Python hasn't always been the most popular language, and it won't always be the most popular language. But according to IEEE, it's peaking right now. Python is the king. And that means there's a huge amount of resources out there to help you upskill into learning Python and also solve problems you may encounter with Python. So you can do that the old-fashioned way and go to Stack Overflow and type in words, or you can use one of these large language models that's been trained on the corpus of Python and Stack Overflow and get semi-meaningful answers sometimes. Rui and Briak, you guys have anything to contribute?
I think I put a little note in there saying don't always trust ChatGPT. But also don't always trust someone else's code as well. Right. I think would be the other thing. Yeah, agreed.
Cool. So related to Python is this thing called Jupyter. So Jupyter, according to their website, is an open source project to support interactive data science and scientific computing. It started out being something to support Python, but has since broadened its scope to support a wide number of languages. And the piece we're interested in is something called the Jupyter Notebook. And I think the Jupyter Notebook is a great platform for learning. I don't use it in practice as much when I'm doing an applied problem, but as far as a teaching platform, it's fantastic because it has a pretty tight coupling of annotations. You can have equations and explanations and piece of live code, and then get some immediate feedback below that live code, some sort of output, usually a graph or a figure of some type. So you can sit there quickly and iterate and experiment and change the code a little bit and see results happening almost in real time. So I think it's a really nice platform for learning.
Looks good.
Yeah. And so when I was getting ready for this webinar, I was, of course, Googling, learning, retention, students, teaching. So I came across this cool thing called the learning pyramid. And I can't believe I haven't seen this sooner, because I think this is something I had suspected for a while, that if you really want to learn something, if you want to retain something and learn it and know how to do it, it's more about practicing doing it rather than either watching someone else do it through a demonstration or even worse, a lecture, right? Lectures are the worst approach to learning if you want to actually retain and become proficient with something. And so again, what we're trying to target with these Jupyter notebooks is this practice doing piece down here at the bottom. So on that topic of learning, I'm going to pontificate a little bit here. I don't feel like, in general, academia is serving the groundwater modeling industry in terms of teaching predictive modeling in the university setting. There are some exceptions to this rule. I know there are some people out there who are doing this, but in a general sense, I think a lot of us come out of school and have to learn a lot of new topics on the job, on the fly, in the heat of battle to become proficient with decision support modeling. And I think that lack of education component is probably the main reason GMDSI was formed. And so GMDSI has a lot of existing materials on theory and concepts, on mechanics and workflows in the form of webinars and monographs, and also some existing tutorials that Rui has worked on. And what we're trying to do with these notebooks is just supplement those existing materials with another approach using scripting to implement the workflows and the mechanics. Rui, do you want to say anything about those existing tutorials?
So I'd say those existing tutorials, they kind of complement what we've done in the Jupyter notebooks, but rather than relying on Python to do each of the steps, they're actually forcing you to effectively go hands-on and mess around with files and things like that. So especially for people who are very new to the pest world, they are probably very useful to actually get a deeper understanding of the mechanics of all of the software and how to actually troubleshoot and things like that. So if you're moving from like the GUI world and modeling mostly in GUIs and so on. And this is kind of the beginning of moving into using PES. Then I would actually start there rather than going straight into Python. But then transition into the Python Jupyter Notebook kind of world for real applied work, which is kind of the path that I took, I suppose. But yeah, that's just my personal opinion.
Yeah, that's a good point, because the Python piece has also been designed to abstract away a lot of those gory details around looking at files and file manipulation. Mm-hmm. But when things go wrong, you got to be able to pop the hood and get under there and know what to do with those files and know how to diagnose problems. So the notebooks, they again are designed to facilitate learning by practicing doing. They were co-funded by the USGS and with GMDSI. They're available on GitHub here. I posted this link also in the chat for today's webinar. And currently there's 36 fully worked notebooks that cover a wide range of topics under that broad umbrella of decision support modeling. So the notebooks were originally developed at the USGS as a collaboration between Randy Hunt, Mike Feenan, and myself as part of the curriculum for a 5-day in-person, what we call fire hose workshop, where we just sort of overload everyone with lots of information for 5 straight days. And we'll talk more about that in a little bit. And then later, GMDSI provided some funding to standardize the materials, to expand the content that was there, and also Rui provided a lot of nice annotation and interpretation in those notebooks to help people facilitate some self-study. And Brioc's also been pretty instrumental in that process as of late.
So if you find typos a mistake, it's probably my fault in converting it from the USGS stuff.
I mean, that's kind of what I was implying, Rui.
But don't email it to me, please.
I've definitely injected some as well, Rui. It's not just you.
Okay, cool.
So at the highest level, there's 3 sort of categories of notebooks. We have the theory and the concepts, and those are what we would call the intro to notebooks. And then we have the mechanics in part 1, where we're again trying to build understanding by doing the theory and the concepts in practice. And then the workflow notebooks, the part 2 notebooks, is where we sort of tie it all together like the dude's rug, right? We take all of those mechanical pieces and we stream them together with one set of ModFlow files and one set of observations, and we run through an entire gambit of setting up the interface, building the objective function, doing Monte Carlo, history matching, blah, 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 all the way down the line using that same set of model files. So it's just trying to demonstrate what a full suite workflow might actually look like. As you might have guessed, it's using the Freiberg model. I'm a big fan of this model. I use it. It's very easy to publish. That's the main reason I like to use it. But it's based on a model from David Freiberg in 1988, where he was one of the first people to show that there's a counterintuitive relationship between fitting your model to historic observations and predictive ability. We've updated the model to be in ModFlow 6. It does a little bit of particle tracking with ModPath 7. We've added SFR in this very realistic, completely linear surface water network running from north to south in the model. And mostly the model is stable and fast running, which is a prerequisite, I think, for just about any meaningful predictive analysis. So the intro to notebooks, this is where we're trying to sort of demonstrate what can be done with these theories and concepts to build some level of understanding, not in a completely abstract sense, but not in necessarily a specific groundwater modeling sense. So we have things like regression and response surfaces, where we're just looking at curve fitting with noisy observations. We have a notebook that talks about truncated singular value decomposition. We have notebooks that talk about variograms and kriging and geostatistics. We have an interactive notebook that talks about Bayes equation. We have some explanation of first order second moment analysis, the black magic that is first order second moment analysis, and then also some things about objective function formulation. And just to give you a flavor of it, it is graphical and it is interactive. So we have this Bayesian notebook over here. You can see my cursor, where you have little slider bars for the first and second moment of the prior and the likelihood, and you can see what the analytical posterior looks like. We actually do the singular value decomposition on a grayscale image. So you can look at how bringing in additional singular components leads to image reconstruction, because that's a nice analogy, I think, to how the SVD works on a Jacobian matrix. And then we have geostatistics, like I said, and response surfaces and first or second moment things. So I think, yeah, at least for me, we tried to put some of the things we learned, Randy and Mike and Rui and I and Briak had learned along the way, in sort of those aha moments for us. We tried to bake those into these intro notebooks to help bring forward some of the things, at least, that help us better understand these otherwise abstract concepts. And I'm going to let Rui now speak about these notebooks.
So then we have another section. We've called it part one. I mean, we've broken this up into 3 parts, but there are a lot of crossover between them, and some of the concepts and topics show up in each of the parts. But in the part one notebooks, we start to go into a bit more of the nuts and bolts of how to actually apply these concepts within the pest ecosystem. We start to go under the hood, take a look at different file types that you need for a pest interface, go through step by step how you use these software tools or analytical tools, and seeing what they're actually doing rather than just clicking a button and hoping for the best. And we start to go through some of the steps or the core steps of a decision support modeling workflow, or predictive, what are you calling it now, Jeremy? Predictive analytics workflow. But sorry, go again.
That's the term for this week. I'm sure it'll change next week.
Oh, okay. But these notebooks are not actually demonstrating a workflow, but just showing you what's going underneath the hood and some of the mechanics of what the software is doing. And we start gently introducing some of the functionality in PyMu, although just piecemeal and not as in a full workflow. Can you skip the slide? Some of the notebooks in this section, we start off very simple, just looking at the differences between what a trial and error, or what we might call a manual calibration, might look like versus some formal statistical or semi-automated parameter estimation workflow would looks like, and the trade-offs of the two, and why you should not be relying entirely on a trial and error for a real-world workflow. As I mentioned, we go through the basic components of a pest interface. What's a control file? What's a template file? How does pest run a model? How does it see the parameters and see the observations, and so on? And then we start to go into some of the more applied concepts of how we need to design a modeling analyses or modeling workflow in a decision support context. So why do we use lots of parameters versus just relying on 1 or 2? The dangers of overfitting, and so on. And from there, we segue into a bit more of how the algorithms are actually working, what the Gauss-Liebenberg mark, what does that mean? What's actually going on when we're running pest? And it's exploring the forgot the word of what I was going to say, but anyway, how it's getting to a good fit with our measured data, and then stepping into some of the more complex analysis and looking in terms of the parameter sensitivities and how that affects your fit, and then segueing into presenting or going deeper into uncertainty analysis, both FOSM and nonlinear in terms of Monte Carlo. Uncertainty analysis. Next slide, please. So these part one notebooks are not necessarily, as I mentioned, they're not presenting a full real world applied workflow. The idea is to demonstrate the inner workings of the software and some of the core concepts that you need to keep in mind when designing a workflow. So they're very much aimed at people who are either new to modeling or new to the pest ecosystem, or even just wanting a refresher on some of the underlying concepts. And they are not examples of actually how to do things in the real world. And for that, I'll pass you over to Briak, who will present part 2.
Cheers, Rui. I've just realized it's analogy central here. So part 2 is where we go into the wild, and we take all of those nuts and bolts, all of the ingredients that we kind of introduced and defined in the intro 2 and in part 1, and we bring them into real or real-like scripted workflows, working through essentially a similar modeling challenge that you might do with one of your real models. So really, it's getting used to how you tie all of these components together, and also I think going forward, providing, I think all of the notebooks do this really nicely, is provide a bit of a reference to refer back to. Oh, how did I do that before? I'm sure we covered this in the notebooks, and then having a look at some of the syntax, some of the process that might be involved. Do you want to skip forward, Jeremy? Mm-hmm. So really, again, we're sticking to Python, obviously, and we're bringing some of that the glory that's developed within PyEmu into the wild. I guess probably more accurately, it's the zoo, because we're still playing with that classic Freiberg model, but it's really trying to get the user ready to have the confidence to start deploying these workflows on their own problems. So in that vein, we go from the initial Freiberg model all the way through a number of different avenues of PEST, PEST++ type analyses. And we go to high parameter dimensionality, and really everything builds on this PEST setup using the PEST from. So this is where we can rapidly build an interface or a mechanism for interfacing with PEST and PEST++, programmatically using some of the features within PyEmu. Do you want to skip forward, Jeremy? And then once we've got that interface, we're really taking these different avenues and layering on different avenues in the analytical workflow and layering on some complexity. So we'll explore doing prior Monte Carlo analysis, how we might build a Jacobian, do some of the linear uncertainty methods and propagation using FOTM, exploring data worth, workflows where we have that classic GLM inversion with the Jacobian, exploring regularization and the value of regularization, and then a few notebooks where we begin to explore using the iterative ensemble smoother for doing our inversion and uncertainty quantification. And then towards the end, we've got some really fun advanced topics that I'm still getting my head around. So this is cyclic data assimilation, management optimization using PEST-PP opt, and then multi-objective optimization under uncertainty PEST-PP MOU. And they're all kind of different paths that the user can walk down, as exploring different ways of taking these scripted approaches through an analytical process. And there will be more to come, but this is where the notebooks are sitting at the moment. I'll pass back to you, Jeremy.
Awesome. Thanks, guys. Yeah, so like Briak said, there are more to come. We got some things in the hopper that we're working on now. We're looking at some notebooks to demonstrate how you would incorporate soft knowledge stochastically. We were talking about notebooks that do direct predictive hypothesis testing, the new hotness that is data space inversion and ensemble data worth, surrogate assisted MOU, and then also some materials to talk about how we might interact with the forthcoming PyPest utils project that Briak and Mike T and I and Mike Feenan and John Doherty are working on currently. So there's more in the hopper. We're trying to, again, keep these things alive, add to them as our understanding of how to approach predictive modeling is evolving. We hope to keep these notebooks going as well so that other people can follow along and contribute as well. So in the unlikely event that it looks like there's something wrong with one of the notebooks, well, there's a button for that on GitHub, and that's called the issues button. You go over here and you click this and you tell us what broke for you. But let's say you made it through the notebook and it worked syntactically and executed properly, but maybe there was something you didn't quite understand about what's happening in the interpretation of the results. Well, there's this discussions button. So you can click on discussions and you can start a new Q&A discussion, and you can give it the title and whatever text you want it to have. And we will do our best to interact with you and provide some feedback and maybe if we start to see patterns, we can bring in some new materials into the notebooks to help update them to, again, make these more of a learning-centered, community-driven type of material. And so on that topic, we are looking actively for contributors and contributions. So if you've gone through the notebook and you get to the end and you're like, man, if this would have been earlier in this notebook, I would have understood this much sooner in the process and that would have helped. Or, man, there's this one key insight I didn't get until the end of this notebook that should have been somewhere else. Well, there's also a button for that, and that's called pull requests. So if you want to contribute to the notebooks, by all means, please modify the text, change the description, add a new figure, whatever you want to do. We are welcoming of contributions from anybody who wants to get involved. So that should be enough, right? Like, you guys are prepared, take these notebooks, go forth and learn. But there is another dimension to the learning problem, right? We are in the real world and time is money. And there is an efficiency aspect to practice doing, right? I mean, by our very nature, I think all of us applied groundwater modelers have a large amount of tenacity and perseverance, right? We live with the I got this mentality to slog it through, solve the problem, get it done. But some amount of guidance and motivation, I think, can greatly improve the efficiency of how you practice doing your modeling, right? Now I've made this chart, and with this chart, I'm trying to sort of visualize what the relationship between guidance being provided versus your uptake learning rate might actually be. So over here on the left axis, this is you're on your own, banging your face on the keyboard, solving the problem, Googling every other word because you don't understand what's going on. That's one way to learn. And there is a learning happening there. It's not optimal though, right? There's an optimum up here with some guidance. But then when we get over to this side, this is where like the 5-day workshop is happening, right? This is where there's like too much guidance. You're overloading people. The learning rate actually goes down because you just sort of like, overload mode. And so what we're trying to achieve is this optimal rate of learning. So we want to provide some guidance, but we don't want to just do it for you either. And so this is what we're going to try to do with this experiment that we're calling a guided self-study online class. So it's a free course. We're announcing it now. GMDSI has put forward the funding to support Briak and Rui and I and Mike Feenan and Katie Markovich to provide the guidance sessions. But the idea is that the self-study piece means you still put in the time, in the work to build the understanding, to work through these notebook materials. But the guided piece means we're going to meet once a week as a group to provide some social pressure and also some guidance and answer questions, help you move through last week's assignment, maybe give a brief introduction of this week's materials. But this is definitely not us running notebooks while you watch, right? We want to get down to that practice doing, that high retention rate, the high uptake. We want you guys to upskill as much as you can in this Python-based ecosystem. So again, this is going to be interesting. It's an experiment as we're labeling it. There's probably going to be some pivots along the way. We haven't done this before. The idea is there's going to be 2 parallel tracks. 3 of us are going to host weekly sessions in the Australia, New Zealand daytime hours time frame. And then our colleagues, Katie Markovich and Mike Feenan, are going to host similar sessions in the Americas daytime hours. And so we're looking at a 4 to 5 week commitment where we'll probably meet on Friday afternoons. And we're likely going to start the week of September 11th is what we're looking at this point. So I've asked Katie and Mike, who are in the Americas timeframe and hopefully asleep now, to make little videos to introduce themselves. Let's see if this works.
Hey y'all, I'm Katie Markovich. I'm a groundwater modeler at Antera Incorporated, located in Albuquerque, New Mexico, USA. I will be co-leading the inaugural GMDSI tutorial notebook self-guided hybrid session, the Americas edition, with Mike Feenan. And I'm super excited to be part of this because I think these notebooks are an incredible educational resource that GMDSI and USGS teamed up to provide to the community. I know I've benefited from them myself. A bit of background about me. I got an undergraduate degree in geology at UT Austin, where I first discovered my love of all things groundwater. From there, I went on to get a PhD at UC Davis with Graham Fogg, where I was integrating and improving upon quantitative tools to better understand our conceptual conceptualization of mountain groundwater systems. And then I did a postdoc sort of zooming out and also zooming in a way of on mountain block recharge. So looking at how, mountains supply quite a lot of water to lowland aquifer systems, again, combining numerical modeling and some tracer techniques. And then from there, I decided to make the jump from research to applied work, which has led me here to where I'm at with Intera Incorporated, where I get to work with the likes of Jeremy White and many other super talented folks every day on all sorts of interesting uncertainty analysis and decision support, management optimization management optimization questions, using the tools that we'll be discussing it and working through with these GMDSI notebooks. So I'll just leave it at there. Thank you very much. And I look forward to meeting you all in September. Thanks.
Awesome. I'm glad that worked. All right. And then we also have a video. Oops,
Katie Markovich.
if it'll go forward. And we also have a video from Mike Feenan.
Hello, I'm Mike Feenan. I'm a research hydrologist at the U.S. Geological Survey in Madison, Wisconsin in the U.S. And I'm really stoked to be a co-lead on the Americas edition of the kickoff tutorial session with the GMDSI notebooks. These notebooks came out of a lot of work that we did for in-person classes and then collaboration with people in GMDSI. And I think they're a really great start to a great educational tool. I'm really excited to be part of it. A little bit by way of background, I started out in geology at a liberal arts school called Macalester College in Minnesota, and was pretty excited about planetary geology, but turned out that I wasn't going to become an astronaut, so I got into groundwater. And so ended up doing about 8 years of mostly field work and consulting, and I learned a ton there. Toward the end of that time, I stopped being I called myself a geologist. Everyone on the drill rigs called me a dirt looker. But I moved on to modeling and data assimilation uncertainty analysis. That led me to go to Stanford to do a PhD with Peter Keaton on basically inverse theory for groundwater problems. I started a postdoc when that finished with Randy Hunt here at the USGS in Madison, and I have not left. So, I discovered PEST kind of at the end of my PhD career and was instantly excited about the model agnostic nature of the tools and just bringing all this power to a whole variety of applications, something that I think is super valuable. And that's just continued to build with supporting tools, things like PyEMU, having a Python interface, I think has lowered the bar for a lot of applications and making sure that we can make repeatable workflows. And with the advent of PEST++, expanding out into management optimization and iterative ensemble smoother, there's just tons of power in these tools. And I'm really excited to be part of sharing them with you. So looking forward to joining in September. I'm away for the month of August, but I'll be excited to get involved in these hybrid classes when I get back. Thanks a lot.
Awesome. So again, we're going to have these two sessions, one Australia, New Zealand focused, one Americas focused. Seats are limited. It's a 4 to 5 week commitment. We're going to meet on Fridays, probably. We may adjust that some. We'll send out calendar invites once the time gets closer. There's a few prerequisites, right? You got to have a little bit of basic Python and Jupyter, but you've got time now to go out and search the internets and use ChatGPT to upskill quickly if you need to. You got to have that willingness to learn and the time to devote to it. And there's a bit of a logistical problem in that you also have to have the ability to install and configure Python and Jupyter on your machines. In our experience, there are some very, very risk-averse IT departments in the world who have gone to great lengths to protect employees to the point that many cannot install and configure Python on their machines. And if this is the case, there's really not much we can do to help you. And so we've set up a pre-course installation check to make sure that everybody who's going to join the class can in fact install and configure Python in the Jupyter Notebook appropriately. Just because we don't have the ability to help you work with your IT department and get Python and Jupyter installed for you. So registration for the class is in the form of 2 Google Forms. We will be emailing those out after the webinar today. They're actually posted in the chat, and they're also they're also mentioned on the GitHub repository README page. And so the idea is that you'll register once, and then once you've done that, you go through the process of configuring your Python environment, following the instructions that are in the repository. And once you've done that appropriately, there's a notebook you run, and it checks that everything's done. And if it runs right, it gives you a secret code. And you take that secret code, and then you go into another Google form, and you verify that you were able to get your installation to work. And this is what that looks like if you go to the repository today. There's a section on this guided self-study course, and there's the first form to register. Then you do the installation piece, and then once you have that done, you run the notebook that's here, also in the repository. You get the secret code, and you go plug that in down there to make sure that everything's working appropriately. So that about sums it up for today. We're looking forward to these classes. I think they're going to be an interesting experiment in what Mike referred to as hybrid learning. And I think that's about it. If we have any questions, please put those in the Q&A. Otherwise, thanks for your time today.